For the next several lessons, we are going to be studying rational expressions, and today we're going to learn how to reduce rational expressions. A rational expression is a fraction with a polynomial in the numerator and or the denominator. So here are two examples of rational expressions. The first one has a polynomial in the numerator and the denominator. And the second example has a polynomial, that is a binomial, in the denominator. So both of those are rational expressions. And let's see how we're going to work with these. This is really nothing new, but a little practice might help to get us going. And we got 15 over 25. We can reduce that to 3/5 and x4 over x squared. Let's see, we remember how to do that. 4 minus 2 gives us an x squared on the top, and the x is eliminated on the bottom. If you don't remember how to do that, you need to go back to the previous lessons and where we talk about how to add and subtract exponents. So let's get with y squared over y the sixth. And we're going to subtract, but it's going to stay with the y downstairs. Why? It always, pardon the pun, it's always going to stay with the bigger exponent. So it's going to be 6 minus 2. So don't do 6 minus 2 and then put it up here. It's going to stay with the bigger exponent. The bigger exponent is down here. 6 minus 2 is y to the fourth, and that is our final answer, except you might want to move that y in closer to the 5, make it look a little neater. You certainly want to do that for a test, but let's look at the next problem. Okay, and we don't have any variables on top, so the only thing we're going to be able to factor is a number, which is the thing we're supposed to be factoring first anyways. Remember, sign, number, variable, polynomial. So let's factor the number. The only thing that is common to all three of those numbers is 4. And that is what you're going to be left with. Now Mr. Wallace factors out that 2 so that it looks like this. And that's good too. Either way, and by the way, once you factor something out, you don't have to put it back together again. But either way, that's correct. And the reason why he does that is, I believe he factors out an 8 first. I can't remember what he factors out. And that way it's easier to reduce the 28 and the denominator below. But either way, as long as you're factoring all three numbers, that is, all the numbers on the top and all the numbers on the bottom, have to be factored with the same common factor. Don't do this thing where you're factoring the 28 on the top and the first number in the binomial. Don't do that. Okay, let's try something a little bit more serious. Well, here it's a little bit more difficult to see what we need to do unless we completely factor this out. So let's start with the top. Let's see, I can factor a 3 out of the 9 and a 3 out of the 3. Yeah, that's good. And once you do something like this, why don't you look at it again and see if there's anything more you can factor out of there. There's not. So let's go to the bottom. 18 and 6. Well, I can factor a 6 out of 18 and I can factor a 6 out of 6. So let's do that. Okay, well that's interesting. I got a factor. Remember, this is not a term up here, this is a factor. It's in parentheses. So 3x minus 1 over 3x minus 1. Both of those in parentheses. So I can eliminate those. And I probably should have reduced my numbers first, but I didn't. And so 3 over 6 is 1 over 2, or 1/2. And so that is the final answer for that. Obviously that can't be reduced anymore. Let's look at something else. Well, okay, we finally have a polynomial over a polynomial. And let's go through our order of operation for factoring. I don't see a negative sign here. And there might be in the homework. I don't know. Haven't looked real hard. Could be. Keep your eye out for that. Always remember the first thing we factor is that negative sign. The second thing is a number. Well, both of these have a coefficient of 1, so that's not going to do us any good. And a variable, well, I need 5 x's. Now, do not factor x squared over x squared and eliminate them. I cannot tell you how many times I've seen that. That x squared is attached to the entire denominator, all three of those terms. And in the denominator, this x squared is attached to every term in the numerator. It's all attached together. If there's a plus sign or a minus sign. Now, if that was x squared times something, and on the bottom you had x squared times something, that's a different matter. You can eliminate that. But that's not what we have here. Anyways, we went through sign, number, and variable. There was nothing there. Can we factor this polynomial up here? Well, what do you think? That looks like the difference of squares. We got a square here, and we got a square there. 25 is a square, right? You better know that. You better know your squares. By the way, let me run through your squares real quick. Okay, 1 is a square. 4 is a square. Well, it's 2 times 2. 9, that's 3 times 3. 25 is 5 times 5. And 36 is 6 times 6. And 49 is 7 times 7. 8 times 8. 9 times 9. And 10 times 10. Now our squares keep going up. I think the next one is 11, which would be 121. And 12 is 144. I think 13 is 169. You don't really need to know those. It's nice. It's nice. But these are squares that should just jump right out at you. When you see that, you go, okay, that's a square. When you saw that, you should have said, that is a square. I can't tell you how many students say, oh yeah, that's a square, but that's not. No, 25 is a square. Anyways, getting back to the difference of squares, we have a square and a square separated by a minus sign, which means we need to factor that. Good, that's how that factors out. And if you don't remember how to do the difference of squares, go back to the lesson where we covered that. And so here is a trinomial that looks like we can factor it. Not sure. Let's see. We have a 15 here, so let's tear apart that 15. Okay, and I'm going to keep the original trinomial in place until we're done separating it out into binomials. And 1 plus 15 doesn't get us to 8. 1 minus 15 doesn't get us to 8. 5 minus 3 doesn't get us to 8. And 5 plus 3 does get us to 8. Okay, and we have a positive 15, so both of these need to be negative, or both of them need to be positive. Negative 3 and negative 5 is negative 8. That doesn't do us any good. Positive 3 and positive 5 gives us a positive 8, so that's what it's going to be, positive, positive. There we go. And now that we have our binomials factored out, we don't need our trinomial anymore. So why don't we get rid of our trinomial and bring our binomials up to the dividing bar. And now that they're in the parentheses, the plus signs and minus signs don't bother us too much, except that you can't, again, x over x, you can't do that. You can't get rid of that. But x plus 5 I have in a parentheses, as I do x minus 5. And are there any x plus 5s in parentheses downstairs? Now remember, this is not going to work if there's a plus sign here, but there's not. We're multiplying here. We have an x plus 5 over x plus 5. And so we can eliminate that. And that's what our answer will look like. So now you know how to do all this, hopefully, and do a little bit of homework. Do a lot of homework, and you'll get real good at this.